All right, so in 4-6, we learned the last of the acronyms, right, to prove triangles are congruent. So they're all on the slide at the top there. It says, tell whether each pair of triangles is congruent by side, angle, side, angle, side, angle, side, 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 angle, angle, side, or hypotenuse, leg. If it's not possible to prove the triangle is congruent, write NC. So when you look at 1, obviously you've got 2 pairs of angles that are marked as congruent there, yes?
Yes.
What else do you have there that's not yet marked? The reflexive side. So if I have 2 angles and the side that connects them, what is that? Good. 2 looks like this. Again, you've got what? Another reflexive side, okay? So I've got 1 angle, and it's the non-included angle, and then 2 sides. Are these congruent?
No.
Nope. This would be an NC, not congruent, okay? Remember, there's no such thing as side-side angle. Yep.
But it looks like, what would be like?
So the key word you just said is looks like.
Yeah.
Right? It can't just look like it. What were you going to say, that it's like it's a right angle?
Yeah.
Yeah, unless it's marked, you cannot assume it.
But that would like seem like it would work because like you already have one.
All
side.
those looks like, seems like.
No, yeah, but like if you have 2 sides,
Yeah.
you can assume that the third side is going to.
Nope.
Yeah.
Because the angle that's here can move, right? If you're saying you have this side and this side that are marked as congruent, yes, then this angle is not necessarily fixed, right? And if that angle is not fixed, then I can make that spread further apart or closer together, and now it's a completely different triangle, right?
Yeah.
That's why there's no such thing as side-side angle. It's not enough information. All right, then number 3 says to write a 2-column proof given that BD, so I'm going to write this out, BD bisects angle ABC, and angle A is congruent to angle C. So those are my givens. Okay, angle A and C would be here and here. And then BD bisects ABC. What does that tell you?
BD is.
Okay, so you can use that one. You can go straight to BD is congruent to BD. What's that called? Reflexive. And then what does the bisects tell you? Angle A, B, D is congruent to angle D, B, C, or C, B, D, either one. And what's the reason?
The definition of angle bisector.
Definition of angle bisector. Okay, now, so I've got that. Do I have enough information to prove these are congruent?
Yes.
What would be the reason?
Angle
Good. Triangle A, B, D is congruent to triangle C, B, D. Angle, side. It didn't say anything about midpoint. So in order to use the definition of midpoint, it has to tell you it's the midpoint. So if it said D was the midpoint of AC, now you can state that. But without it explicitly saying that it's the midpoint, you can't use it. Connor. It would have to be the side. If you were to use angle, side, angle, this would have to be marked. Those would be the ones that are congruent. Somebody else had their hand up, right? No? Okay. Okay, so for 31, AK, which is this side here, is congruent to CJ, which is this side here. Okay, angle BJK, which is this one here, is congruent to BKJ, which is this one here. And angle A is congruent to angle C. And it wants you to prove that triangle ABK is congruent to CBJ. Okay, so I have the bottom sides, right, already is congruent. That's one side. This side is congruent to this side. And then you've got one angle over here, one angle over here. And then you've got one angle over here, one angle over here. Are these already congruent? What do you use? You don't even need it, right? So like if I were to draw that out separately, this is A, B, K, and this is B, C, J. This one's congruent to this one. This is congruent to this. And this is congruent, I didn't need 3, is to that. So it's already congruent, and my reason would be angle, side, angle. 32 looks like this. This is VW. That's that one that's marked. Is congruent to UW. Angle X is congruent to angle Z. And you're trying to prove that triangle X, W, V, where's V? I did it wrong. X is here, X, W, V is congruent to Z, U. God bless you. So you already have one pair of angles that matches, right? And one pair of sides. What else is there that you haven't used yet? So this is your given. What else is part of that? Both of those triangles. The reflexive angle, which is W, right? Angle W is congruent to angle W, and that's reflexive. And that's here. So again, if you want to separate it out, if it makes it easier for you to see, that's that one. Oops. We just marked those as congruent. These. This is congruent to this, and this is congruent to this. So which of the postulates do you have there? Angle, angle, side. No, angle, side, angle. Yep. So 3 steps. These were not that difficult. Okay, this one says given NKM, which is here, is congruent to LMK, which is here, and L is congruent to N. I want to try to prove these congruent, whether a piece of information is part of that diagram that I haven't used.
Can you say KM? So congruent KM.
Mm-hmm.
Yeah.
So the given is 1. KM is congruent to KM, and that's reflexive. So now I've got this side shape that's this, 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 and then I've got this side of the shape that's this, 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 which is what?
Angle,
Angle,
angle, side.
angle, side.
It's just one KM.
KM and KM. Yeah, was the only step in between. Is that what you said?
No, it's like one line between top two.
Right. Oh, one congruency. Yeah, it doesn't really matter, but yeah. Okay. 34. X is the midpoint of Y, of VY and WZ. And then obviously you've got the rest of that there. All right, so what can I state?
There's vertical angle.
There are vertical angles, so I can do the given, right? Given would be one thing. With or without the given, I can acknowledge the vertical angles. V, X, W is congruent to Z, X, Y. And then what's it mean if it's the midpoint? So this is vertical angles theorem. Don't forget that. You guys often do like postulate or definition. Don't do that. What else is there based on the midpoint?
Vx equals xy.
Good. This one equals this one. This one equals this one. So 3 Vx equals xy. Wx equals xz. And the reason for both of those is the definition of a midpoint. Now are these triangles congruent?
C.
Why?
Okay. Side angle side.
Questions on that one? Okay, last one is triangle ABF. So ABF is here, and DFB is there. It's saying that those things are congruent. Then it says that F is the midpoint of AE, and B is the midpoint of AC. And I'm trying to prove that FDE, this one here, is congruent to BCD, which is this one here, and ABF. Let's start with the midpoint, right? Yep.
AB is congruent to BC and AF is congruent to FE.
Okay. Now what? Yep. What's reflexive? Okay. So if I wanted to go from FDE to BCD, that's the one on the bottom left, the one on the bottom right, they don't share anything, right? There's nothing reflexive there, right? These, there's nothing reflexive this way or this way. If I was comparing these two triangles, then there's a reflexive side, right? But not the yellow ones. But what does it mean that these two triangles are the same?
That if it one's congruent to, like, say, let's just say FDE is congruent to DFB,
Mm-hmm.
would be congruent to ABF.
Why?
Transitive.
You can't use transitive property on a whole triangle. But you can use it on its parts, right? So if that triangle has AB matched up with FD or DF, what's it tell you about AB and DF? They're congruent, right? Yeah. So this is congruent to this. Actually, I should do a 3. 1. Oh, no, that was a single mark. Single mark, right? And this AF, which is first and last, would be congruent to DB. So does it make sense that these sides are starting to overlap? Like if this one here is equal to this one, and this one here is equal to this one, that's the transitive property, right? So if I said that AB is congruent to, if I'm using the initial statement, DF and BF is congruent to FB, well, that's reflexive. I don't even need that one. Let's do the last one. AF is congruent to DB. That's based on the definition of congruent triangles. So if I said they're congruent, so then their parts are congruent, that's true, right? Yes. Okay, so now if you look at what's there, the last thing you've got is that these triangles have two sides the same already, right? And then if this side, let's see, midpoint, this is congruent to this, and this, that's one side. This is congruent to this, and this, that's the other side. And then the angles are congruent, right? So in the top triangle, I could say angle A is equal to angle B, or D, BF, B and F are congruent, and F and B are congruent. And I've got this third reflexive side that's shared on both. Let me clear all this stuff off. Okay, so the last thing we said was that A would be congruent to D, B would be congruent to F, and, oh wait, no, not that F. This one. Okay, do you see anything else going on there? If I said ABF was congruent to DFB, right, which is what I just marked, the red and the, here, let me make it the same color. What's true about those angles?
They're,
Alternate interior, if they're alternate interior, if they're congruent, they're parallel, yes? Which means that this, if these two lines are parallel, and this is a transversal, this will be congruent to this. Do you see that? Yes, that's corresponding. So the first thing I marked was, oh, based on here, A was congruent to D, A, B, F, congruent to B, F, D. That was all part of definition. Then we said AC is parallel to FD. Alternate interior. Good. That one's the converse. And then the next one, correct. So now I've got that these two would be side angle side, right? I marked up all the sides, but side angle side would be congruent. I already did. Thank you. Okay, so the good news is today's stuff is actually like sort of a shortcut for this stuff. okay? But it is the topic of it. So today's stuff, which is 4.8, is going to actually take you from what happens if they are congruent. So if you 4.7, and then we'll do 4.8. If you start with proving two triangles are congruent, God bless you, based on some of the information, then what else can you say is congruent? And that's all the other parts, basically, okay? So it takes it from the next step.
So for number 4, how would you know if they're already parallel?
You don't know they're parallel until you prove that the alternate interior angles are congruent, which was this one here, and this one here. I'm going to do a different color. This and this.
So you would prove that because of definition of congruent.
Correct. So I matched up the sides and I matched up the angles and saw what else could it tell me. If they're parallel, then if they're parallel, it carries down into those triangles as well. Because you could also, this one links to this one if they're parallel too. Like you could go a bunch of different ways on that once they're parallel. Okay. So 4.7 is called using congruent triangles. And it basically says this: if the two triangles are congruent, then all their corresponding parts are congruent. We already know this. All this does is gives you a shortcut to using it. So if you are trying to prove parts of a triangle are congruent, two parts of two triangles are congruent, then your goal is to prove the two triangles are congruent using a shortcut. So we're going to use side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg, to prove the two triangles are congruent. And then once I've established the two triangles are congruent, I can say any remaining pair of corresponding parts, which could be two corresponding sides or two corresponding angles, are congruent. And the reason is that big long thing, corresponding parts of congruent triangles are congruent, or this acronym, CPCTC, which stands for corresponding parts of congruent triangles are congruent. CPCTC. So there's a pattern to these proofs. The proofs you've already done, the goal is to get the triangles to be proven congruent, and you have 5 options there, right? Those acronyms that are already there. So if I give you a proof that said prove the triangles are congruent, 5 options, figure out which one works, solve it. If it then says prove that a remaining angle, like angle A is congruent to angle C, then you're going to have to prove the triangles are congruent and then go one step further and say CPCTC.
Okay, so we're pretty much ending with CPCTC.
Most of the time, yes. There are a couple of scenarios where it might be different. I'll get to those. Yeah.
So that is, you use that to prove the two parts of an angle are congruent.
Of a triangle. After you already prove the triangles are congruent. So you must have a statement that says this, whatever that is, first. Then you can say CPCTC. Basically. And if you don't remember CPCTC, then you say definition of congruent triangles, because it's the same damn thing. Okay?
Really? That's the same thing?
Because it's going a little bit further and saying that I've already proven the triangles as congruent, and so all of their corresponding parts are congruent. That's all. It's the same thing. It's the same thing. It's shorter. Don't you like shortcuts?
How's this shorter? I don't get it.
CP. All right. So notice that the prove is not that the triangles are congruent. Do you see that? That's the difference, right? Does this make sense? My end goal is different now. My end goal is past that they're congruent. So my goal is to prove they're congruent, and then one more thing in this case. Yes, CPCTC. Good. All right. So it says QR bisects QPS. So that's step 1. PR bisects QPS. And PQ is congruent to PS. So that one I can mark. PQ is congruent to PS. Okay? What else do you have going on in that triangle that's going to help you prove that these triangles are congruent?
Deflection.
Okay, the reflexive side, PR, is congruent to PR.
And then definition of angle bisect.
Good. So because it bisects QPS, it's on this side, right?
Yeah.
I can say those two are congruent. So I can say QPR is congruent to SPR. Definition of angle bisector or bisector. I would have given you either one.
Now they're.
Now my triangles are congruent, yes?
Yes.
What's the reason?
Angle, side angle. I mean, a side angle.
Side angle.
Good.
No.
Don't you have to say it a certain way that, yeah.
Now, if these two triangles are congruent, then all the remaining corresponding parts are congruent. This is congruent to this. This is congruent to this. This is congruent to this, which is what gets you Q is congruent to S. CPCTC.
But you also say definition
Definition of congruent triangles, sure. CPCTC.
How do you remember that?
It's my job.
Yeah, that's like.
Let's be honest.
A P and a T in the middle is three C's.
Yeah.
A P and a T in the middle of three C's.
Yep, it's 3 C's and a PT. Yeah.
It's not
It's
that hard.
congruent. Parts of course of congruent triangles are congruent. Yeah. Okay.
Wait.
All right. So same diagram, but different given information, different proof information this time, right? This time I just gave you that the segment bisects the two angles. You don't know anything about the sides yet. Yes. So what information can I state? The reflexive side is there. State it. Make your life easier. Get yourself the point on the proof. That's the easy part. Now what?
Angle QPR is congruent to the angle.
Okay, so this time it says it's bisecting both sides, right?
Alright, so you have angle QPR is congruent to angle RPS and angle QRP is congruent to SRP.
Speak English. Really?
I understood you. You're speaking geometry. I totally get it.
Well, not all of us use geometry.
That sounds like a personal problem. All right, so QPR is congruent to SPR because it said it bisects the left angle. And then QRP is congruent to SRP because it said it bisected the right angle. This time both angles. Last time it just said one angle. And the reason there is what?
Definition.
Definition of angle bisector.
Good. Do you have enough information to prove these triangles are congruent?
Yes.
What do you have?
Angle side.
Which would be? QPR, SPR, angle, side angle. So then if the triangles are congruent, all of their corresponding parts are congruent, which means QR is congruent, or RQ is congruent to RS. And the reason there? You guys are stubborn. CPCTC. Good?
Nope.
Well, good as it's gonna get. Now notice that your proof is different. What's happening here?
Parallel line.
Parallel lines. Those are not part of congruent triangles, no?
But like alternate.
Ah, but we know how to prove lines parallel, right? So if I wanted to prove WX was congruent to ZY, if I wanted to prove that those were parallel, what could I prove? What did you say? 1 and 2. If 1 and 2 were congruent, would those lines be parallel? Does that make sense? Yes? So I got to get to the point where 1 and 2 are congruent. 1's in one triangle, 2's in the other one. Yes? So let's prove these triangles congruent. Once they're congruent, then I can use alternate interior angles. So I'm going to start with WX is congruent to YZ, and ZW is congruent to XY.
Oh, AB side.
Not yet. Let's get there. But yes, you are right. XY. Okay, then somebody said it, the reflexive side, right? ZX is congruent to ZX. That's reflexive. Side comes next.
Pardon the interruption, but Jaylene Garcia, fishing for student services. Jaylene Garcia, fishing for student services. Thank you.
I went W, then Z, then X, so I have to go Y, then Z, then X. And that side. Shh. You guys, hush. Then we said we needed to show angle 1 is congruent to angle 2, which is now the case because of CPCTC. Then the lines are parallel. Alternate interior.
WX is parallel to ZY because of alternate interior.
What did he alternate?
Alternate interior angles converse.
Converse.
Yep, because you're proving the lines are parallel. So that's kind of like earlier you asked me if it will always end, right? Gio, was that you? Will it always end with CPCT? And I said sometimes it goes a step further. Something like that. Or like, let's say I had 2 segments and then I wanted to prove that something was the midpoint of that segment. Then I would show the 2 segments are equal to each other and then the definition of midpoint. Yeah, so sometimes you go one step further. But usually it's that pattern. You got to prove the triangles are congruent. You got to use CPCTC and then go from there.
So if it's parallel, then I have to do like
Parallel, you got to do something. Either alternate interior, corresponding. You're going to find one of those and then do parallel. Yep.
What other things are we doing proofs besides triangle?
Oh, it goes for a while. We'll get into quadrilaterals and stuff. Okay. So 4A is isosceles and equilateral triangles. Okay. A lot of this stuff you guys already know. We're just giving it official names. So we know an isosceles triangle has 2 congruent sides. The parts of these have names, right? So the 2 congruent sides are called legs. They're not always in this location. This could have rotated around, okay? But they are the congruent sides. So those 2 are congruent to each other. Those are called the legs. The non-congruent side is called the base. There's only one base. Sometimes it's on the bottom and sometimes it's not. It's still the base. It's just the non-congruent side. The angles opposite the congruent legs are called base angles. So the ones opposite the legs are called base angles. And the one opposite the base is called the vertex angle.
Are the base angles equal?
It's one of the theorems. Yep.
Nice one, Con.
Good job. You could teach today. The first theorem is called the base angles theorem. And it says if the 2 sides of the triangle are congruent, then the angles opposite them are also congruent. So because these 2 sides are marked as congruent, the angles opposite them would also be congruent to each other. That's called the base angles theorem. For 8. Anybody still copying that down?
It's like if you have like 2 sides that are equal to each other, you want to prove side and side, you can just do that.
You'd have to have 2, like if you had 2 triangles. Yeah.
I thought the base was the hypotenuse.
That. No, there's no base. There's no base in a right triangle. The base is only in the isosceles. All right, the converse of that is obviously the converse, right? Switch the order. Now it says if 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So if B is congruent to C, then the side opposite B, which is AC, is congruent to the side opposite C, which is AB. This is the converse of the base angles theorem, or base angles converse, okay? Base angles theorem converse. The order doesn't matter on the word. It's about corollaries, right? Corollaries are things that are easily determined based on theorems. So these are 2 that you probably have already figured out. We've even talked about a couple of them, okay? The corollary to the base angles theorem says if a triangle is equilateral, then it's equiangular. So if it's equilateral, then it's equiangular. And the corollary to the converse of the base angles theorem says if a triangle is equilateral or equiangular, then it's equilateral.
Are we gonna ever use these?
Yeah?
Well, just because last time we got the triangle and we never used it.
The triangle. The corollary was the right angle one.
Yeah.
You've used that one.
Is equal or angular?
All right, let's work through this and then we'll stop, okay? This says find the value of x. So if you look at A, that's an isosceles triangle, yes? If the sides are congruent, then what's congruent? The angles are congruent. So if this is x, then this is also x. What's true about all three angles in a triangle? They add up to 180, which means if I take away that 30, that 150 is going to get divided between those other two, which means x is 75. We're back to the math. We like this. Yes.
Minus 30.
150, and then there's two of those, so divided by 2, right? Because they're both the same. You have to know they're equal first. Yeah. All right, so B, and your book will do this to you to throw you off. There's 3 side lengths there. Do not add them up and set them equal to 180, first of all, because someone's going to do that. I'm telling you now, don't do that. Secondly is, how do you know which ones are congruent? Good. I go opposite the angles, right? So opposite this angle is that side. Opposite this angle is that side, which means 2x minus 4 equals x plus 5. And x equals 9.
Wait, why is it 2x plus 2?
What about that 2?
It's there to totally throw you off.
But what is it for?
If it maybe it would say classify the triangle based on its sides, and you'd have to plug the x back in. It is entirely there to throw you off. So you don't set 2x minus 4 equal to 2x plus 2. These two are the ones that are congruent. This is not. It's there to throw you off. It's not equilateral, but if these two are congruent, then those two are congruent. So you take away the 30 and divide by 2. All right, and then C. Again, they're giving you more information than you need, but also less information than you have in the inside, right? What's true about all the angles inside? 180, so 62 plus 56. 118. Subtract it from 180. 62, so this is 62. So then, opposite this 62 and opposite this 62 are congruent, which means x is 42.
That's the base.
I do not.
You add these two,
What?
you get 1.
Be super clear about this, that you have homework that is due tomorrow for 4-7. That is due tomorrow.
Yes.
Okay? Your 4-8 will be due on Wednesday. You can start it, however, because also tomorrow will be your chapter test review. So if you can get a head start, if you've got an extra 15 minutes, you want to get a head start on a 4-8, I would advise it so that tomorrow you can focus on your review.